Hey everybody, this is Larry. This is day 29 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Leetcode. Join me on Leetcode, what? Join me on Discord. Let me know what you think about today's farm. Yeah. Well, whether you celebrate it or not, or well, I am Chinese by history or whatever. Yeah, I don't know what I'm saying, but anyway, Happy Chinese New Year is what I meant to say, or Lunar New Year, or whatever it is that you know it is in your locality or whatever. Yeah, I hope everyone's having a good one. I'm a little bit early because I guess technically Chinese New Year is tomorrow, which is for me, which is whenever this video gets out, right? So yeah, hope everyone's celebrating well. Hope everyone has a good year of the snake. There's probably some political commentary on that, but that's not even the point. I don't know. Anyway, yeah. A quick update on my leg is that I was in a lot of pain after yesterday's video. But I think the worst is over. I went to see a doctor. I might have already talked about that part, but she agreed that it was hilarious how I got my injury, but also that just keep doing what I'm doing, just rest and ice and all these other things, right? And sold me a very expensive compression sock. But in any case, today though, or last night, I did have a crazy fever that lasted for hours. And I was just like, the usual sweats and cold and all these things. But I took it as a good sign, honestly though, because it means that the peak inflammation is over. So, or ideally, so I'm not fevery right now. Still a lot of pain after that, but the last hour or so I've been a little bit better. But that's because maybe I've just been curled up in bed doing nothing. So I don't know. But yeah, but I am okay enough to kind of come up to come up to do this video. So hopefully that'll be good. Anyway, yeah. Let's do this. I don't know if y'all need all the background, but I feel like I want to keep y'all updated. If not, you could just fast forward. And if you wanted to fast forward but you didn't fast forward, well, next time you know. Anyway, okay, let's take a look at today's problem. We have redundant connection 684. Redundant, just like all the things I've been talking about. No. But okay, a tree is undirected. In this problem, a tree is undirected, connected. That is connected and no cycles. This clearly has a cycle though, right? Or am I confused? Okay, keep reading. Maybe that'll help. You're given a graph that started as a tree with one additional edge. The added edge has two different vertices from 1 to n and was not an edge that already exists. Okay? A graph is represented as an array edge, and there's an edge between. Return an edge that can be removed such that, the multiple answer, return the answer that occurs last in the input. Okay, I mean, so basically, I wouldn't say this is common, but I guess in competitive, it does come up here and there, the idea of it, right? I mean, there's just a lot of things about trees that, in competitive anyway, that are known, right? I mean, I know that there are, the textbook definition of trees, but there's also just a lot of observations that you kind of just like, for me anyway, honestly, take for granted a little bit just because I've done so many tree problems in my life, right? And some of them maybe subtle, some of it is very quote unquote obvious once you say it, right? Like for example, you have n nodes in a tree, there's n minus 1 edges, right? Okay, yeah, that's almost a definition, but it's also something that if when some problems don't tell you, then you may not realize it, right? And the other thing is what was the other thing I was going to say? Maybe I forgot already. Oh yeah, there's a unique simple path between every two nodes. Sometimes there's something that comes out. Anyway, there are a lot of random properties like this that I mean, there are more for sure, right? I'm not, this isn't a tree video. And even if it was, I don't know if I could go for all of them. But yeah, Anyway, so what happens when you have a tree, and by definition, a tree doesn't have a cycle? You could maybe use a pigeonhole or something like that if the tree is fully connected anyway, right? Meaning if you don't have a forest with end nodes or something. But in any case, yeah, then by definition, if you have end nodes and edges, then you will have a cycle, right? And basically this problem is saying, okay, this problem is saying that, okay, well, we added a tree, we added an edge, now there's a cycle. Now we want to remove it such that the graph remains a tree. So you have to basically, if you think about it, it just means that you have to find a cycle, and then yeah, you have to find a cycle, and then what? And then just remove an edge from it. In theory, you can remove any edge, but if there are multiple answers, you have to return the one that occurred last in input, which is a weird tiebreaker, but that's fine. Like, we're smart people, we could do that part. That part is easy. If you have everything else, right? So okay, and of course, then it just becomes cycle finding, right? Which is something that you almost certainly should be familiar with and be competent with, right? Yeah, I mean, okay. I'm trying to debate whether I should do it recursively or with a queue or something. Or I guess maybe it could still be a stack, just an explicit stack. I'm trying to find a coin is what I'm looking at for on my desk, so I could flip a coin. I guess I have, the reason why like I'm way immobile right now is because my leg is still on a elevated thing because my foot still hurts. But I have a coin here. Hang on. All right. Oh, this is a $1 coin that I got from El Salvador. But yeah, all right. You can't really see this, so I could just cheat and lie to you, but you just have to take my word for it. All right, heads, I'll do it with a queue, and tails, I'll do it with a stack. Okay, I don't know what that is. It's a tails. I'll do it with a stack. Okay, well, look, I don't know. Anyway, okay. Yeah, okay, right. So first, what are these are just odd edges. We probably have to figure out how we want to rewrite. I think the first thing to do is actually try to figure out how to process this, right? And we could obviously just do an adjacency list, and that's not that difficult, right? So let's do it. But you just have to keep track of, because the tiebreaker is a little bit awkward, but that's not that bad. If we have to, we can just do a lookup table, right? So yeah. Okay. So yeah, adjacency list is equal to right. Okay, and then now without loss of generality, we can actually just take any node. Is it does it always start at 1? Is it a 1 index? Yeah, okay, so then we just start at 1, right? Usually I would just start at 0, but that's fine. Right, so queue. Wait, did we say stack or queue? I think we said stack. Okay, fine. Yeah, and then we just append the I almost did one. Right, and then here we may want to do yeah, just to keep it nice, right? Nice and whatever. And anyway, while length of, how do I write it with a stack? I think it is this way, but I actually don't remember how to do it with, did I say stack? I don't remember anymore, but okay. But anyway, let's just do it with stack. I actually don't remember how to do it with stack without doing, I mean, I could do it recursively, that's how I usually do it, but I want to do it with an explicit stack. The reason is honestly just for myself. It's a little bit selfish. I don't know. I feel like I haven't done it in a while, so maybe that's a good practice anyway. So yeah. Okay, yeah. So then now is you go to stack dot. Ooh, it's not a pop though, right? How do you do it with an implicit stack? I don't remember. Oh yeah. Do you pop? I don't think you pop yet, right? Well, sorry, friends, that you're gonna have to suffer this with me, because I don't remember how to do it with. I mean, yeah, there's nothing that tricky about it. We'll do it, but it just will be much slower than I am normally. If it's a little bit awkward actually the way that I'm doing it. I think was what I want. Maybe I could do it with an implicit stack. Oh, I mean, but not the recursive one, right? And what I mean by that is I probably should do it like this, right? And this part is technically not true because then you want a 2-cycle thing, right, to work. What you want is just not directly, right? There are no repeated edges. There's no repeating edges means that there's no like 1 2 2 1. Because it's undirected, so I guess it would be repeated, so that's a little bit awkward. I'm thinking about that edge case. No pun intended, but yeah. Too lazy. If we is not equal to previous of now, then we just go previous of we is equal to now s dot push it on the stack. How do I do a stack iteratively? I feel like I'm doing it crazy man style without keeping track of like iterators. I guess that's how you have to do it. You have to keep track of like the indexes so that the next time you pop, you go to the next item. That is very confusing. Man, maybe there's a reason why I haven't done this in a while. This way. Is it too late to change it to a cube? Yeah, let's just change it to a queue. I think that's how you would have to do it. You keep track of the indexes on the adjacency list traversed and stuff, but I guess that is a little bit messy. Yeah, I'm just gonna do it recursively actually. I feel like that is. Sorry, friends. So then you have go 1 -1 and then see what happens. All right. And then we want previous of node is equal to parent, right? So we don't even need this. I don't think we need scene anymore because we technically is an implicit part of previous. We don't need a stack anymore, right? And then now we just traverse, right? So for v in adjacency list of node, if v is not equal to parent, then we just calculate node v parent node, right? And then here, I guess this is the critical part. If previous of node is not none, or if node is in previous, oops, then that means that we have found a loop, right? Yeah, we found a loop. So then now we just go up the parent chain, right? From node. Yeah, wow, this is kind of annoying. Or maybe I'm just bad. Could be both. Okay, so right? That means that we want to go up, right? So okay. Yeah, I mean that's fine. So we basically go up all the way to parent. Yeah. And we go all the way up until node.previous. So basically the two things, right? So we're at node, we have the current parent, but we've seen it before with another thing, right? So that means that we want to go up all the way. So current is equal to node, and we want to keep going while current is not equal to previous of node, because previous of node is not the same as parent, or shouldn't be. Then current is equal to previous of node. No, current, right? So then now all the edges will be here, right? So okay, let's just put in let's e dot append current. And this should basically end with, yeah, right? We'll print e real quick, just to kind of see if we're going nuts, a little bit nuts, but okay, so we go from, that's not great, huh? Do I do this multiple times by accident? Is that why? Let's see, let's assert length of e is equal to 0. Yeah, okay, so I do call it multiple times. Why is that? So okay, so it's empty. Oh, no, that doesn't make sense. 1 negative, if node is in previous. So 1 3, so that means that 3, right? So we probably just go from 1 2 to 3 3 1. So that's right. Oh, we have to start at parent because node by definition. Yeah, okay. This is silly. That's why. Well, I'm silly rather. Current is equal to parent. Previous. Current should be -1 when. Oh, that's why. Because this is. Okay. A lot of silly mistakes apparently. Okay, still silly mistake, but. Oh wait, no. This part was right. Whoops. It should be node. Huh? Where does it come into play? But also, why is it trying to do this multiple times? I think that's the bigger reason. 1 3, we printed out 1 3, and now 3 1. basically, okay, so the recursion goes 1 2, and then should be 2 3, but okay, so it goes 2 3, but then after that it goes all the way back, right? But it shouldn't. It should go 3 1 before it goes to 1 3, right? I think that's why. I am really bad at this, apparently. Alright, let's just put everything out, and then to true. So yeah, so -1 1 2 2 3, and then 3 1 should trigger stuff. Oh, this is the 3 1. It's just that oh no, there's 3 1, and then the 1 triggers. So then we try to do it from parent. We go 3 2 1 da, 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 and then now it goes to 1 3. But that's because edge is already done. We already calculate the answer. It's just that I was lazy on the return. So okay, that's fine then. Yeah, okay, that is actually what we were hoping to expect mostly. But yeah, if length of edge is greater than 0, then we're already done. So we recalculate. Okay, so yeah, so we have, so that's the edges, right? 3 to 2, 2 to 1, 1 to -1. And we could double check this one too, right? Yeah, 5, you could see 5 is not here. So so here we see the cycle, right? So now we just have to collect the edges, and here we have to find the one that's indexed. That's a little bit messy. Do I have to put in the right order that they give us? Is A sub I is always okay, so actually that makes it more straightforward. So I mean, we can just do a lookup, right? It's not that whatever. Lookup, right? So lookup of UE is equal to index, and here we enumerate index, and then here now okay, so then now for UE in pairwise of E, right? We have to sort UE, convert it back to tuple. You could write this in a cleaner way for sure. Maybe like fine. Maybe like min max is equal to min of UE, max of UE. Maybe that's a little bit cleaner. I don't know. You tell me. But yeah, so so now we have to look for the one with the latest index, right? So this is actually kind of annoying. So best is equal to I don't know. So later in the index of the largest, right? So best is equal to -1. Best result is equal to none, maybe, right? So best. So then now lookup of M and MX. So that's the thing. If best is greater than it, then best is equal to it, and best R is equal to just the tuple at this thing, and that's it. So technically, I guess it's whatever. Oh, what? Oh, because we do the -1 at the end. Huh. I guess we could pop off the -1. Will always have -1 at the end? I don't think so. It's only -1 at the end if 1 is part of the cycle, right? So yeah, so maybe we can check it. So if E of -1 is equal to -1, then E dot pop. That's an ugly hack. Alright, well, I hate you too. That's weird, right? Oh no, it's the other way. That's why. Okay, because it's supposed to be later. That's why. Okay, so I mean it's wrong, but at least it's happily wrong. Okay, 3 4. Why? My thing is 4 3 2. Oh, huh. I see. Because the 4 nodes are part of the cycle, but I didn't connect the last edge. So maybe and that is such a lazy hack. I don't know. I don't even know if this is right. I'm just doing crazy stuff, man. Crazy man, crazy man. Oh no, 1 5. Oh, because 1 5 is not an edge, huh? Okay, so maybe I missed a case. I mean, this is what happens when you hack, right? It is what happens. Is that especially when you don't test your hack. So okay, so this is the thing. But in this case, I need to visualize this, right? 1, 2, 2, 4, 4, 3, 3, 5, 2, 4, 2, 5. So why is 1 on this? 1 is not part of the cycle. That is actually the actual reason why. So actually, it's this part is wrong. Previous of node. Right. Okay. Let's see. One is negative 1, 2. So the cycle is should be 2, 3, 4, 5. 2 is 1, but it should never get to 1, right? Because 1 is the previous. Okay, I did this loop wrong, I guess that's why. Yeah, I kind of hacked that in, but then I didn't really think about it, honestly. This is what happens when you don't think about it. Yeah. And I think this thing would never come up just because we never do the. Why would you add the thing? So I guess that was the reason, is that we added this hack, but we shouldn't have. Okay, there we go. Really silly. But yeah, what's the complexity here, right? Well, we just do a regular depth first search very slowly, but depth first search 26 minutes. Yikes. I've been very slow lately. I don't know why. Maybe that's fine, but yeah. Yeah, this is just a regular cycle finding. I don't know. I am a bit slow today. But yeah, this is linear time, linear space, right? This is linear space. This is linear space. This is linear time for obvious reasons, and the recursion just looks at every node, every edge once. So we are very Gucci there, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Hopefully tomorrow I'll my leg will be, you know, good, or my foot will be good. It's swollen like a balloon. Feel like I'm like bouncing, except for every bounce there is pain. So not the good type, not the fun type of balloons. But anyway, thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.